As always, it's the belay accessories that are problematic, and I know something about it, and I'm going to share something with you about it today. Thank you so much for coming. I'm Dominik. I'm a Flutter GDE, and I work at a company called Visible, where we are essentially a Fitbit for ill people with chronic illnesses, and we do a lot of Bluetooth stuff as well. Hence, I knew how to troubleshoot my clicker. Anyway, good to have you here. If you want to reach out to me, you can just scan the QR code. And as we are, I think, all accustomed to, whenever you see a QR code, especially on my slides, just scan it, and you're going to have some fun. And in just a few seconds, so now you have your phones ready and pointing at the screen, I would like you to go to this QR code. I'm going to give you a couple of seconds, because what I want to know is on a qualitative level, what kind of apps are you building? Because this is going to be quite interesting for me to understand whether you're building just a simple customer-facing apps, or are you building something that's a bit more advanced? So we have the Slido here. And yeah, and if you could just type, what kind of apps are you building? Yeah, I can see a lot of e-commerce, but at the same time, banking, sports, social fitness, food delivery, industrial health tracker, telephony, time tracking, so many different topics. And I hope that you kind of see where I'm going with that, because it's also maybe opportunity for you to chat between each other about different things in different topics. Let me just come back. This is kind of cool. I will publish this on my Twitter after the talk, because I think it shows how cool the ecosystem is. Yeah, and nobody is writing anything silly. That's cool. All right. So, as mobile developers, especially in Flutter, in smaller teams especially, as we grow, we face a lot of different topics: UI, UX, animations, navigation, offline support. If anybody has been on my talk last year, they know all about it. System permissions, dependencies, feature flags, all of that stuff. And as you grow, month over month, year over year, you suddenly realize that you gotta do something when the app is not actually active on the screen, that you have to do something that you were not probably used to. We as mobile developers tend to just stay within this little rectangular box. We don't really have to worry about multiple windows, multiple processes, especially in Flutter. However, at some point, the time comes to implement some processing in the background. And I think on one hand, it's a good thing with Flutter that it kind of constrains you into just worrying about the app when it's actively used by the user. That just frees up your mind from many different troubles and topics. So when the user opens the app, you can just do whatever you want. When they leave it, you just don't care about anything. However, I think at some point you will have to face a challenge of either synchronizing something in the background if you have an offline first app, or uploading or downloading something despite the user leaving the app. And my journey with background processing started back in the times when I was implementing enterprise backends with .NET. And back then, a concept of just a background worker, a job scheduler, was just something that you would normally do. Everything was kind of done using some kind of background processing. Then at a super cool company called LeanCode, I worked with Xamarin, then with Flutter. And with Xamarin, we had also some notion of background processing. And then suddenly, in Flutter ecosystem, my perspective was that there's almost no one actually using background processing for a while. And only when I joined the company called Visible 2 years ago, we actually had to do some background processing because we moved to offline first. And we also had a Bluetooth integration. So for instance, I had to probably learn from scratch how to do it from the point of view of a Flutter developer, how to, for instance, connect to a wearable armband that I'm wearing right now. And I'm recording my heart rate continuously just to see later after the talk how intense the talk was. We also, this is mostly used for ill people to actually let them pace, kind of make their day. Whereas for me, I'm mostly debugging this and wearing this couple of devices at the same time. And yeah, just to double check if the heart rate is correct. It's not like 180 all the time. Anyway, we have a bunch of BLE native code to integrate the Android and iOS app. And essentially, all of that happens when the app is inactive. User is active in the app maybe for 5 to 10 minutes a day. And for the 23 hours in a day, we got to do a lot of background processing. And my journey with Flutter and native started out there. And also last year on this stage, I was talking about offline first. And this meant that we also had to do things outside of the life cycle. Today, we're going to talk about some, I would say, obvious use cases, but I think it's important or inspirational just to be aware. Maybe as a newcomer, as a new person, you don't really had a chance to work with that. So you didn't really have a chance to work with that. So today, I will probably try to put some light on that. Then, obviously, as the talk suggests, we're going to try to achieve it with Flutter. And finally, I will try to drop my hot take here. And hopefully, some of you will agree with me. All right, let's start for some use cases. Just quickly go for them. So in our case, Visible, we had to do offline first. And what we are doing, for instance, in our app is that when you leave the app, we schedule a task to synchronize later. In the test version of the app, we actually show a notification. We don't show it in the production version. So, but for the testing purposes, we show the notification. So when you leave the app, the process keeps on running and it's synchronizing the data, uploading heart rate samples, downloading some data from the backend for that. So we try to run it, for instance, when the user connects the device to the charger. This makes sure that if they have any actions queued for execution, they are getting run right there. The other case is when you have to upload something or fetch something. And actually, I had a friend the other day asking me how to do it in Flutter. They had to upload 2 gigabytes of files. And essentially, normally, you would just not do it inside of Flutter. There are some system APIs that handle chunked uploads out of the app lifecycle. Obviously, there are some limitations. But in fact, you should be able just to do it like, for instance, OneDrive does. Or when you post a new tweet on Twitter, you will see that the action happens out of the main lifecycle. You can leave the app and the tweet will be sent. So this is something that I think has kind of been forgotten in Flutter ecosystem. I would like you to learn and realize that it's actually quite easy to achieve. And the last but not least, the one that we are using right now, but you may see it in the wild, for instance, when you have a phone key to your car. So for instance, Tesla cars, they unlock themselves when you approach them and you have the app running. But app doesn't necessarily need to be running. What they are using is they are waking up the app when you approach the car using the BLE notification. And then they have probably some authentication negotiation to open up the car. And that's the use case that we also have, for instance, in the morning when the user turns on their armband. We don't really want them to go to the app and open it. We want the app to wake up automatically to start the HR monitoring. And when you try to look for ways how to do background processing, the first result in Google is in Flutter, you can just use isolates. And that's like the first link that you'll find. And obviously, like in some way, isolates, which you probably are aware of. If not, there are some amazing talks both at Fluttercon, Flutter and Friends, available online that explain how isolates work. But isolates, essentially, they need to run in Flutter, within the Flutter engine. So if you want to do something in the background, does it mean that you have to have the Flutter app running? In certain way, yes, and we use isolates a lot for this particular case. For instance, we have a lot of data processing when the app is actually active that is happening in the isolates. Sometimes we may have like 15 isolates running at the same time doing some processing. But what is, I think, more interesting, especially to me, is spinning up a new isolate, which is obviously embedded within the Flutter engine from the native code, from parts of the app that may actually work out of the lifecycle. Today we will not have a lot of code, but this is one sample where we try to use the isolates when the app is running. So for instance, we have a GraphQL endpoint, and it can return big chunks of data at a time. So when you try to decode the string response to JSON, it actually can cause junk if you have multiple requests coming at the same time. However, in GraphQL, for instance, I think it applies to every HTTP library. You can provide your own decoder, which will then just pass the string to new isolate. New isolate is gonna decode it and give you back a parsed JSON. This way, you can have multiple responses being handled without affecting the performance. Let's say when you're animating something. But that's a done thing. That's already solved, and you may have already tried compute in your app. However, the interesting part is like trying to invoke a new isolate when the app is not running. So for instance, you may be familiar with Firebase callbacks that are invoked when you get a push notification. These are top-level functions that can do something when the push notification arrives. In our case, for instance, we have a foreground service, and it can also invoke a Dart callback. On iOS, there is not a really concept of a foreground service, but you can do very similar thing with newly added live activities. And another use case would be when the user taps on the widget. And actually today, there's gonna be a cool talk about home screen widgets. So if you're into that, you can actually run Dart code from within a home screen widget if you need that. And we're gonna see how it's actually done. We're gonna show a quick demo here. Hopefully it's gonna be like a good starting point for you. And essentially we can invoke a native, a Flutter engine from the native platform in like 3 major steps. So imagine we have a Flutter app, and underneath that there's just a native embedder, for instance, Android. So what we want to do is that we want to send some data from Flutter to native. The easiest way is just to use method channels. You could use Pigeon, you could use Dart FFI, you could use JNI-Gen. There's so many ways for native interop, and there's also a talk about it tomorrow, I think. Once you establish the connection to the native platform, you just start the foreground service. It's quite easy on Android, although as you will learn, it's kind of discouraged right now. Within this foreground service, you can just spin up a new Flutter engine. You provide an entry point. You tell the Flutter engine what kind of function does it need to call. And then once you have your foreground service running, your Flutter engine running, you can establish a second connection between your foreground service and your new Flutter engine. Once you have it, you can communicate back and forth. And once you're done, you can just dispose of all of that. And we're going to see a short demonstration, nothing fancy. We have a simple Flutter app with just a column and 2 buttons. And we're going to start by creating a method channel. And as I mentioned, that's quite, I would say, simplistic approach. In a real production, I would recommend trying to use something more resilient, like Pigeon or JNI-Gen, and that is still experimental. We just create 2 functions, start and stop. These will essentially start the foreground service on the native side. Nothing groundbreaking here. Once we have it, we are going to go to our main activity. Of course, you could do this easily in the plugin code, but here we are just dealing with a simple app. And in the configure Flutter engine on the main activity, we just override the function. When the Flutter engine gets connected, we create a method channel using this Flutter engine where we're gonna handle the start and stop calls. Starting service on Android, I think it may sound like it's complicated, but Android used to be filled with a lot of services. It has changed in Android 8. Right now, you would mostly use foreground services, and it's going to change in Android 15 as well. The services are not going to be that easy to deal with. And then, of course, we stop the service on the stop callback. Once we have it, we can go to our foreground service. And this sample is taken from an amazing article that I can recommend. where we are, like in our foreground service, we're just gonna handle the onStart command. For those that don't know, communication with services works by receiving and sending intents using Android. So essentially here, this is the entry point to the service. When the service starts, we have 5 seconds for this start the foreground notifications for the foreground service, and then we are going to call start Dart service. Here is the juicy part where we are getting the Flutter engine from this class. I'm going to show you in a second how it works. And once we have the new Flutter engine, we can just establish a connection again using a new method channel. Here, whenever we get the update, we are going to update our notification. The Flutter utils class is taken from the sample that I mentioned. And essentially, it's a class hosting a couple of static methods, maintaining the Flutter engines for your application, because essentially you can have multiple Flutter engines. For instance, in the case of adding Flutter to an existing app. Here we are just getting the Flutter engine from engine group cache. We defined the entry point. So in this particular case, that's just the main.dart and the function name background main. Once we have the engine, we store it in cache if you ever need to use this again. And of course, once you're done with the job, you can just destroy the engine, remove it from cache. Back to the Dart side. Here we are going to define our top-level function. Nothing like tricky about it. It's a top-level static function that can be also annotated to let Dart VM know that this is an entry point. And here I'm gonna just create a simple timer that's gonna tick from 100 to 0. And on every tick, it's gonna just call the update method. But of course, you can build up your communication interface to be much more complicated. And here, the callback is gonna be received on the native side in the new Flutter engine. Here, just updating the notification. Once we have it, we can run the app. There's a little bit more setup necessary, but once we start the service, we are going to see the notification that just goes from 0 to 1. And what is cool about this approach is that essentially you can now just swipe away the app. Does not apply to newer Android versions like Android 15. And once you have it, you can just keep the foreground service running. The Dart code is running all the time. When we come back to the app, we can either automatically or on demand connect to the service again and, for instance, invoke any other functions. In this particular case, I'm just stopping the service. And the sample for that is going to be available, and you will be able to play with that on your own. Just to give you a little bit more resources to learn from, a couple years ago, Razvan Lung had an amazing talk at droidcon London about how all of that communication works between isolates, between a Flutter engine and native code. What kind of protocols can you define to communicate back and forth on a little bit lower level than I've shown today? But it's like entire talk just about this. And the other thing that I want to recommend is an article from also a couple years ago about adding Flutter foreground service to an existing Android app, and also how to show new Flutter views inside of fragments. Again, an article worthy of a talk by itself. And whenever you want to do something like that, I personally say it's good to understand how it works, but at the same time, in a day-to-day work, you're just gonna try to use some package or plugin. And there are some amazing, really well-maintained plugins out there. The background fetch by Transistor Software Work Manager by Flutter Community that we personally at Visible use. There's also a way to run background service. They all abstract away all of that I've shown in a second ago. And if you want to just upload or download the file and don't really want to deal with downloading or like writing the code natively, there's also a couple of plugins just for that, with a sole purpose of either uploading or downloading. All right. This is where I'm gonna try to drop my hot take. And I hope that you will a little bit agree with me Or maybe you will try to argue with me. Let's see in the Q&A section. So in case of our app, Visible, we had a bit of research at the very beginning, whether we want to maintain the connection with our Bluetooth armband in Dart only, or are we capable and brave enough to actually implement this natively? We had our goals and plans. We kind of knew what we wanted to build. And in the end, what happened after a couple of weeks of trials, we realized that in this particular case, when we have a lot of native code to write, a lot of native SDKs to deal with, the lifecycle of the foreground service and things like that, we actually realized it's going to be easier to write this all natively than in Dart. And I know on a Flutter conference, that's maybe not the best outtake, but what I want to kind of share with you is the fact that perhaps as Flutter developer, kind of stepping or just taking one step towards this is going to just elevate or make your developer life and your position on the market so much better. You don't have to be afraid of writing the native code from time to time. And what is amazing about Flutter is that you actually can do this pretty easily compared to some other platforms. It takes a single method channel to communicate back and forth with the native platform, and it's going to be even easier in the future. So if you ever have a native SDK that doesn't have a Flutter package, sometimes it just takes 20 minutes of your time to bind some methods if you need them, and you don't really have to be feeling locked down. And fun fact about Kotlin is that it's almost like Dart, so you don't really have to learn a new language. And with Swift, it's obviously a little bit different, but it's also a cool language to know and get inspired with. So I hope that I just planted a seed in you to kind of try something like that. So what options do we have to work with that? On Android, so many ways. Android has been designed to actually support a lot of background processes, background services. The most, I would say, common for a couple of years has been foreground service, but it's becoming discouraged by Android team. They are adding a lot of different types of foreground services. So they essentially recommend falling back to some more basic background work options, like Work Manager, Job Scheduler. They are mostly the same thing when it comes to different rules and how it works. And I think it's worthy to know how they work. And then recently, I think starting from Android 14, Android team is also recommending something called user-initiated data transfer. So this would be more aligned with things like when you want to upload something to the cloud or synchronize your data with the backend on user action, essentially. This is much more forgiving compared to background jobs, as it doesn't, for instance, you cannot span 100 background services or foreground services. On Android, you will be limited by the quota, and user-initiated data transfers are a little bit more forgiving. They don't have this quota. I haven't tried them personally, but that's something that when you, for instance, want to upload a bigger file, may be a way to go. And in case of iOS, we probably just need a cricket sound. It's a little bit tricky. We're going to look into that in a second. So on Android, we decided to use a foreground service. And our use case is very specific. We have a wearable armband that needs to be connected all the time with our phone. Not every wearable device needs to have this, but in our case, we had to, and I'm looking at the person that actually implemented this with Smile. We have a foreground service that runs, and it's just a bunch of native code that maintains the connectivity. And it was the most reliable way. User can see when the foreground service is running or not. They can get some updates for that. And with the scale of the BLE integration or even the local database. So for instance, last year I mentioned that, but we have a SQLite database that we access both from Flutter and native. So in Flutter, we just use Drift library to access the SQLite using Dart FFI. And on native, we just use a respective SQLite library. So this way, we can pass a bigger amounts of data between Flutter and native, or Flutter and home screen widget, which is super cool. And it just connects these two together in much more, I would say, hardened way. Yeah, so we kind of just went ahead. I only had some native experience, but like as I went through that for a couple of months, we realized, like, we learned how it works. We obviously made a lot of mistakes. One of the biggest mistakes that we had was that we are essentially were just draining the battery like hell, doing too much work, and saving too much data to the disk, things like that. And you learn this by just kind of iterating on that. As we've seen a slide ago, iOS is a little bit trickier, but at the same time, so some say, I don't really know how true is that, but some say that iOS has never been designed to support background work, and anything that relates to background work is just like a patch on top of the current design. And when you look at the APIs that they expose, it feels like this is actually true. So official way is just to use background task scheduler, and this allows you to run either short or longer tasks. You can define whether it runs when the charger is connected, whether Wi-Fi is connected, things like that. And this obviously lets you just run like a Swift callback. But interesting thing is that essentially when this function gets invoked, your entire application is also running. Like your app delegate gets run. So this is quite interesting. And we have found at Visible 2 tricky ways that work for us that are not necessarily official ones. And but it's also worth to know that there are some other ways if you need to do something longer. So one of the common tricks is just to send high priority push notification, silent push notification, and this will run callback even when the app has been swiped away. And a thing that we use at Visible is something called state restoration app relaunch, and we're gonna look into that in just a few seconds. When it comes to Swift code, yeah, we're like going across borders here. There was a bit of Dart, Kotlin, now Swift. In iOS, it's, I think, even easier or like simpler than in Android, because you can only define a callback that will be run when a task of a given ID gets invoked. You have to predefine all of your background jobs by providing them into info plist file. When you leave the app, you just let the system know, hey, please, very kindly ask you to run this background job whenever you're available. So in this particular case, when the external charger is connected. And essentially, this callback that we have at the top is going to be run. But I mentioned the trick that we use, and I'm going to sell it to you as especially if you're working with wearables. This is a cool idea where whenever the Bluetooth device is in the range of your phone and you're paired and you're listening to a specific service, the app is going to stay alive. If you leave it, if you go to any other app, the app more or less it will not be suspended. And if it's going to be suspended, when the BLE device comes back into range, it's going to wake it up without actually showing to you. And as I mentioned a couple of minutes ago, what it means, your entire app is running. Like it's not like a single service is being run, it's like entire app. What it means that essentially also the Flutter is running. And that's one of the cases where we actually made a significant mistake where we just assumed that when the user minimizes the app, goes away from the app, we will not use any battery, but in fact, we were just draining the battery, like the most of all the apps. What was happening is that all of our WebSocket connections, the database queries, logging, writes to the disk, things like that, they were still running because Flutter was not aware that, the main view controller that hosts Flutter engine was not aware that the app is not actually should be paused. So in this particular case, what we had to do was essentially fake the Flutter app pausing. I mean, it didn't render, like the rendering of animations or widgets did not happen, But like if you had any timer or a WebSocket connection, it would just continuously fetch the data, and we were just draining the battery. Right now, I'm happy to say that aside from just the some base energy usage from just the app running and the BLE connection, we're quite a good citizen on iOS. We don't drain the battery that much. But it took some weeks, if not months, to realize this once we had the app running in production. A similar mechanism is going to be available, or is available on Android, which is called companion device pairing, available for a couple of versions now. And it's also something that can be alternative to foreground service. When you have a BLE accessory that you paired with, when you're back in range, it's going to wake up the app. But in this particular case, as Android supports background execution, it's just going to call a specified callback, so that you don't really have to like spin up entire app. All right, let's wrap it up and do some final remarks. I hope that you have kind of got the impression here, or like my advocacy here, that when you're a Flutter developer and you have seen all of these amazing types of apps that you build, essentially, you're not just Flutter developers, but you're also Android and iOS. If you do desktop, you're also Mac and Windows and Linux developers. And in a certain way, I so much enjoy the fact that like I can work on all of these platforms and I'm not constrained just to Android or just to iOS. You're essentially becoming product engineers, not only Flutter developers. And I want you to leave with a feeling that you can just go and try writing some native code. Bear in mind that some changes are coming to Android, especially with Android 15. It's going to be a little bit more closer to iOS. So when you swipe away the app, and by the way, at the end of the talk, there's going to be a QR code with a survey where I want to ask you how many of you are swiping away the app when you leave it. I think that's kind of interesting because I was super surprised to see my friends when they leave Instagram or something, they just swipe it away. And I was like, why do you do it? And they were like, that's just my habit. I do it always. And yesterday, a couple of other people also said it. So it's going to be super interesting in just a few minutes. And the last final thought, try it yourself. There's going to be some good resources and talks today, tomorrow, and on Friday that are somewhat related to what I've mentioned today. Today, Norbert is going to talk about how the Dart VM works. Lucas is going to talk about how to store the data when you leave the app. Tomorrow, there's going to be an amazing talk about how the native interop is going to look like in the future, and I'm super excited about it. And then on Friday, I can recommend talk about foreground services, as probably like 50% of this talk was already about them. There's also some more reading on my website. And if you would like, I highly ask you to fill the form, fill the survey. Let me know whether you swipe away the app or not, because I think that's kind of cool to know whether like 50% of users or like 50% of developers, do they still swipe away the app when they leave it? Because it just makes my life so much harder. Thank you so much. That was native background processing with Flutter. If you have any questions, I'm super open to listen to them. And I hope to have a chat with you later. Thank you so much.